Hello, in this video we are finding the Cartesian equation of a plane, and our question is find the Cartesian equation of a plane through the points P and Q parallel to the line with vector equation this. So to start with is for us to get to know that our plane has a normal, and if this line is parallel to the plane, then the direction vector of this line will be perpendicular to the normal of the plane, in that when you dot the two, it will equal to 0. Again, these 2 points are contained in the line, so their vector PQ dot with the normal will also give us 0. So let's start with this line. So the direction vector of this line, let's call it D, is, for the I component is 0, for the J component the coefficient of this alpha is 2, and for the co-component the coefficient of alpha is -1. So when we get our normal, which we don't know, as ABC, and we dot this with that, our end product will be 0. So let's try to dot that. So that is 0 to -1 dot ABC is equal to 0. When we dot this times that 0, then this is 2b minus c is equal to 0. Let me call this one equation 1. Then when we use our P and Q, as I explained in the beginning, we are going to dot PQ with N. So we shall subtract the Q minus P. So when you subtract this minus that, let me first write it. 3 -1 0, -1 1, 3 -1 1, then minus 1 0 -2, 1 0 -2. So subtracting these two, we shall get 2 -1 3. Then we dot this with N. So PQ dot N, it will be the same as 2 -1 3 dot with ABC, and this one should give us a 0. So when we dot this is 2a minus b plus 3c equals to a 0. We call it equation 2. So equation 1 and equation 2, we are going to solve them. Using parameters. So we can first let b equal to lambda, and b equaling to lambda, c will be, from the first equation, this c will equal to 2b, so c equals to 2 lambda. C equals to 2 lambda. Then a, we substitute into the second equation, the value of b, which is lambda, and the value of c, which is 2 lambda, find a. So that will be 2a minus lambda plus 3 times 2 lambda equals to 0. So 2a then plus 5 lambda is equal to 0. So a is equal to negative 5 lambda over 2. That's our value of a. Now, having gotten these values, we substitute them back to our equation of the normal, to our vector of the normal, which is ABC. And our a is negative 5 over 2 lambda, b is lambda, and c is 2 lambda. When I factorize out lambda over 2, I'll be left with negative 5 inside, and then 2 and 4. So any value multiplied with this is parallel to the normal. So we can take this to be our normal. So n our n equals to negative 5, 2 and 4. And having gotten n, we can use that n in the formula r dot n is equal to a dot n. And since our question is asking for the Cartesian equation, our r will be written in x, y, z. And then a, we are going to use this p as a, 1, 0, negative 2. So a is 1, 0, negative 2 dot n, which is negative 5 to 4. And then r is x, y, z, dot it with n, is negative 5 to 4. So this gives us negative 5x plus 2y plus 4z equals to, this times that, negative 5 plus 0 minus 8. So our final answer will be negative 5x plus 2y plus 4z equaling to negative 13. This is our Cartesian equation of the plane. Thank you.